Hello, welcome back to Comparative. Let's have a review of the branches of the aortic arch, or the arch of the aorta, which supplies blood to the anterior parts of the body. So coming from the heart, specifically from the left ventricle, the blood is now deoxygenated, having been to the lungs. So now blood will be pumped into this huge artery here that arches immediately, going to the dorsal thoracic wall. So this is the arch of the aorta, and this portion of the aorta that descends down to the dorsal thoracic wall and eventually reaching down there into the abdominal cavity. This is the thoracic aorta, and then once it reaches the abdominal cavity, it becomes the abdominal aorta. But it's still basically the same artery, the aorta, having different names in different portions of the body. So let's examine in this video the branches of the aortic arch and the thoracic aorta. The arch of the aorta has two branches in the cat, going anteriorly to supply the forelimbs and the head and neck region. In other mammals, like in humans, there would be three, but we have a cat specimen here, so there will only be two. This one, the much larger branch, is the brachiocephalic artery, and then the other one toward the left is the left subclavian artery. So it's asymmetric, because the right subclavian artery, the counterpart of this one, would branch out from the brachiocephalic. Right, so I think it's better to follow first the left subclavian artery, because whatever the branches of the left subclavian, those will be the same branches of the right subclavian. So we only need to follow one. So left subclavian artery, and one branch going to the sternum is the internal mammary or internal thoracic vein. Right, and once it reaches the abdominal wall, it will become the superior epigastric artery. And there are successive branches of the subclavian here before it goes out of the rib cage, and those branches are going dorsally. They're diving towards the backside of the animal. So you have to dig underneath the subclavian to find them. So this is one branch. I hope you can see it. So that's the vertebral artery, supplying blood to the brain, and it, just like the vertebral vein, it's one of the vessels contained within the vertebro-arterial canal of the cervical vertebrae. And then if you just move more anteriorly, there's another branch there diving deep. It's the costal cervical artery, supplying blood to the rib cage, for example, and also the deep neck muscles. And then just before the subclavian goes out of the thoracic cavity, it leaves off a branch towards the shoulders. If you trace it, it will be going to the shoulder. That's a transverse, no, not yet the transverse, but the thyrocervical artery. So you see, it's named thyrocervical because it will eventually split. One of its branches will go to the shoulders as the transverse scapular artery, and the other one will go to the thyroid gland, right? The thyroid artery. That's why it's called thyrocervical artery. So you see this thyrocervical, and it's this one. It's one of the branches of the thyrocervical going to the shoulders. That's the transverse scapular artery. And then finally, the subclavian passes over the rib and enters the axillary region. So now it's called the axillary artery. The axillary artery, right? And it has branches. One of its branches going to the shoulders is the subscapular artery. Subscapular artery. And then here, once it reaches the upper arm, it becomes the brachial artery. Okay, and then now we follow the brachiocephalic artery, this one, and then shortly it will divide to give rise to the left common carotid artery. This is the continuation of the left carotid artery to supply blood to the head and also the brain. And then the remainder of the brachiocephalic artery will split again, now giving rise to the right common carotid artery. So mas naunang lumabas si left common carotid artery, and then later the right common carotid artery, and then whatever remains of the brachiocephalic will be the right subclavian artery, which, just like the left counterpart, will give rise to the branches supplying the forelimb. So we won't need to follow it anymore, but let's follow the common carotids. So brachiocephalic, left common carotid, and then the brachiocephalic will split one more time to give rise to the right common carotid, and then the left, or rather the right subclavian artery. Is the right common carotid, and I think we have one branch here of the right common carotid. Yep. Going to the thyroid gland. So the common carotid has many branches, but we won't examine all of them. But there's one branch going to the thyroid gland. It's this brownish organ here. That's the thyroid gland, and this is the right common carotid. So that branch is the superior thyroid artery. And then eventually the common carotid here in the head region will split into the internal and external carotid arteries, supplying various parts of the head. Let's trace the thoracic aorta. So the thoracic aorta is this huge artery on the back side of the thorax, and you see that it gives rise to various intercostal arteries supplying the intercostal muscles of the rib cage, intercostal arteries. And by the way, you see this brown vessel-like structure? That's not actually a blood vessel running alongside the thoracic aorta. That's a lymphatic duct. That's called the thoracic duct, and it's part of the lymphatic system. So it actually collects lymphatic fluid from the abdominal viscera. Right? You see, if you review your digestive physiology, fats that have been absorbed by the intestines do not go directly into the circulation, to the blood circulation. They have a different route via the lymphatic system. And so that fatty lymphatic fluid or lymph fluid will, from the viscera, will be drained by this thoracic duct. And if you trace the thoracic duct, it actually should have a connection with the external jugular vein or near the base of the external jugular. So all of that fatty lymphatic fluid will be returned to the blood circulation. And in the next video, we examine the branches of the abdominal aorta.